Hello, Apply 30. Welcome back and welcome to part 2. We looked at z-scores in the first part. Now we're moving on to z-scores using z-score tables. So we're using the same information before, but the beauty of applied math is we can just utilize the work that someone else has done for us. In fact, even in university stats, you'd be using the z-score tables. So I'm going to show you how you can work with that. You have some z-score tables in your textbooks. They're complete, so use them. Just reference them as much as you need. They're super, super helpful. They're on page 592 and 593, if I'm remembering correctly. Those should be the last 2 pages of actual content in your textbook, so right before the credits. If you want to look there, you can. It might be overwhelming to start with, but I'll be using that to solve this problem. Now, the problem is working with IQ scores. So the question is, if a person scores 119 on an IQ test, how does their score compare to the general population? Well, it's probably wise to understand what an IQ test is first. It's an intelligence quotient, so it's a test to analyze someone's degree of intelligence in a specific setting, in a specific set of time. So it's not the best standardized test to analyze people's intelligence, but it's one that's been around for a while, and there are some patterns that we can get off of it. The average for people on an IQ test is 100. So if you score 100, you are bang average. I think the Canadian average is something like 98, so we're a little bit below. I think the American average is like 95, so they're a little bit below as well. So we're not doing so hot in Canada and US, but maybe you guys can work on getting our average back up. Now, a person could score, for example, 119 on an IQ test. What does that mean? Right? Compared to the general population, how much greater or less than is that value? And just so you can see what that means on our normal distribution, I'm going to shade all the values that are less than 119. There we are. So that's approximately 75% of the curve. So 119 is about in the 75th percentile. Okay. Now, if we're comparing an IQ test to a general mean, we can't just compare this 119 to 100 because it depends on what country you're from, how many people there are, what group of people you're comparing to. It's just not standard. So we have to standardize it somehow, and that's where the z-scores come into play. So a good starting point is maybe calculating the z-score for this set of data. So let's do that. So if you remember, we're going to start with our equation, and then we'll plug the numbers in and see what kind of score we get. Okay, and there we are. We end up getting a score of 1.266. In case you're wondering where the numbers come from, x is the value that I'm concerned about, so that's 119, that's what we're comparing. Our mean will be mu, so our mean is always in the middle of our normal curve, so that's 100. And our standard deviation is the size of each increment. So I'm moving each increment by 15, so our standard deviation is 15. So plugging that all together, we get positive 1.266. Great. What does that do for us? How does that help us? Well, the next thing that we did, based on the information we had before, is we graphed that on a standard curve. So let me show you what that looks like. Ta-da! There's our standardized normal curve, and darn it, looks exactly the same as a regular normal distribution. So that really hasn't gotten us anywhere. We can do all this information, which is great sometimes, but the way the question was worded here, that doesn't help us. That doesn't tell me how this person did compared to everyone else. And so that's where we're going to look at the tables. All right, so now we have a Z table. Now, I've filled this one out for you. You don't have to memorize or know how to copy them down or anything. In the back of your book, as mentioned before, on page 592 and 593, you have your own Z tables. They're gigantic, very overwhelming, zillions of numbers. That's okay. I'm just going to show you how to work with them, and then you know how to tackle problems with Z tables. All we've got so far is this number 1.266. So one limitation of the Z tables that we're working with, they only have up to 3 placeholders, so we can only use 3 digits. And our z-score that we calculated has more than 3 digits. So we're going to have to round it so that there's only 3 that we work with. So that means 1.266 is going to be 1.27. And then we can use our Z table and locate 1.27. So in one column, we can find 1.2. That's over there. And on the other column, we can find out whatever is remaining. So what plus 1.2 gives us 1.27? Well, 1.2 plus 0.07 will give us 1.27. And then it's kind of like the game of Battleship. We have to follow those numbers until they meet each other. So this 1.2, we're going to follow it horizontally all the way to the end. And at 0.07, we're going to follow it vertically. And that leaves us with this one tile which says 0.898. What does that number mean? It's a percentage. Our z-score tables are giving us percentage values. So that means that this score of 119 on the IQ test ends up being greater than 89.8% of people that have taken the test. So our previous estimation, or my previous estimation of 75%, that was totally off. And I mean, we probably could have figured that out if we really tried to doctor with the normal distribution. Right, remember this first segment is 34% plus 34%, 13%, and so on and so forth. You end up with like 89-ish. But using a Z table is a lot more efficient once we get some practice with it. So that's working with Z tables. I'm going to give you a chance to practice all of it now, Z scores and Z tables. And like I said before, there's a bit of a learning curve. I think you're going to do great with it. So take your time. Any questions, absolutely just send me a message and we'll take it from there.